Welcome! This is a second section of our Spark course. In this section, we'll be looking at the distributed data frame optimization pitfalls that occurs when you're starting developing application in Apache Spark framework. First, we will see how to make our computations parallel using partitions. Next, we will see how to define robust custom functions. We will see the mechanism of understanding and creating user-defined functions. First video will be about understanding logical plans that are hiding the truth. We'll be examining the physical plans of query on data frame and RDD. At the end, there will be a grasp of slow interpreted lambdas, very advanced topic, and we'll see how Spark is speeding up our code by performing code generation. And this is a first video in which we'll be making our computations parallel. So we'll be using partitions. We will be examining number of partitions of RDD. Next, we will use coalesce method to affect number of partitions, but we will see that this method is not always what you want. This is one of the other problems that also will occur. Next, we will see repartition and we will compare it with the coalesce method. So we have our partitions test. First test is a very simple one. We just load data that should be somehow partitioned. So we are creating a mock RDD with 100,000 elements, similar to the previous section. And then we are just asserting how many partitions does it have. And first problem arises here. We will see that this data source has only 2 partitions. So loading data using some make RDD is not an efficient way to parallelize our computation. When we have 2 partitions, it means that we are able to execute those operations on up to 2 executors. If you will have 1, then both partitions will be executed by that one. If we will have 2, then one executor will take 1 partition and second one second partition. But if you will have 3, the third executor will sit idle. Third executor will not have any computation to perform. So we can extract the information about partitions just taking the partitions array that have some additional information and taking length of that array. And we can execute input, some filtering, mapping. As we remember from the previous section, we should firstly filter, then map. And we are triggering our computation by issuing the action collect. And the question is on how many executors that computation can be distributed and calculated in parallel. So we answer that question that on 2. But let's start this test. And we can see that this is a fact, that it has 2 executors indeed. But right now, let's issue the coalesce method. Coalesce method is taking the one parameter, number of partitions that we want. After we will issue the coalesce, we will assert that our length is still 2 and everything will be exactly the same as in the previous example. Why does it happen? It's happening because coalesce does not change number of partitions upwards, only downwards. So if we have, for example, 1000 partitions and we are calling to coalesce, it will take those partitions and make 10 partitions for it. But other situation is not possible. If we have less than that parameter, it will not work. So let's start this test and see how does it behave. We can see that we still have 2 partitions. Only use case that we wanted using coalesce is that maybe we can make partitions lower. So if we will pass 1 to coalesce, then resulting dataset will have only 1 partition. Our test is failing because, yes, should be 2, but we changed it to 1. So coalesce is only useful if we want to have less partition. So you need to be aware of that. And third test, that is testing the proper method in this specific example, is repartition. Repartition is doing best effort to change that partition scheme without any constraint. So if our dataset has 1 partition and we want to create million partitions, it will try to do it. Also, if our data has million and you want to try one, it will do it as well. So it works in the both ways. So right now we are passing 10 partitions, and then we are asserting our partitions dataset has 2 partitions. And then our computation can be executed on 10 executors. So let's start this test. We can see that number of partitions is 10. So the lesson learned from this exercise is in most cases use repartition.